Let's solve x to the 2/3 minus 5x to the 1/3 equals 0. We're going to start by factoring. We can factor out an x to the 1/3, so x to the least exponent. So we're going to have x to the 1/3 times the quantity x to the 2/3 minus 1/3. So when we factor out 1/3, we're going to subtract it, and then minus 5 is equal to 0. So I have x to the 1/3 times the quantity x to the 1/3 minus 5 equals 0. So now I set each factor equal to 0. I have x to the 1/3 equals 0. Well, that's just 0. We can cube both sides, but 0 cubed is 0. And then x to the 1/3 minus 5 equals 0. That's x to the 1/3 equals 5. And now I'm going to cube both sides. So x to the 1/3 cubed, that's x to the 1, or x is equal to 125. So my two solutions are x equals 0 and x equals 125. Let's solve 4x to the negative 1/2 minus x to the 3/2 equals 0. So we'll go ahead and factor out what's common in each term. So we're going to take out x to the smallest exponent, x to the negative 1/2. What's left over from the first term is just the 4. And then from the second term, I have x to the 3/2 minus a negative 1/2. And that equals 0. So now I have x to the negative 1/2 times the quantity 4 minus x. And now in the exponent, 3/2 minus negative 1/2, that's 3/2 plus 1/2, that's 4/2. Well, 4 divided by 2 is 2. So I just have 4 minus x squared equals 0. Well, x to the negative 1/2, that's going to go ahead and move to the denominator so that it can become a positive exponent. So I have 4 minus x squared over x to the 1/2 equals 0. And 4 minus x squared factors to the difference of squares. It's 2 minus x, 2 plus x, all over x to the 1/2. I'm actually going to write that as the square root of x, and then equals 0. Now, to solve this, a quotient equals 0 when the numerator equals 0. So I'm going to set the two factors in the numerator equal to 0. 2 minus x and 2 plus x equals 0. So here, if I add the x to the other side, I get 2 equals x, or x equals 2. And here, if I subtract the 2, I get x equals negative 2. And it's tempting to go ahead and just stop and box these in. However, the denominator here is the square root of x. And so there's a limitation to the values that we can substitute into this function. I can't have the denominator equal 0, but I also can't have a negative underneath the square root. So in other words, the domain of this entire function has to be x values. So the domain has to be x values greater than 0. So I can't have anything underneath the square root be negative. It has to be positive, and it can't equal 0 because this is in the denominator. So the domain of this function is restricted to only positive numbers. So that means I cannot let x equal negative 2 be a solution. So while it does make the numerator equal 0, it causes an issue in the denominator. It's going to make the denominator a negative underneath an even root. So the only solution is x equals 2. Now let's solve 2x to the negative 5/3 plus x to the negative 2/3 equals 0. We'll start by factoring out x to the negative 5/3, x to the smaller exponent. Then what's left is a 2 from the first factor plus x to the negative 2/3 minus negative 5/3 equals 0. So I have x to the negative 5/3 times the quantity 2 plus x, and this time I have negative 2/3 minus minus, so that's plus 5/3. Well, 5/3 minus 2/3, that's 3 over 3, which is just x to the first. So we happen to just have 2 plus x equals 0. Now, let's move that x to the negative 5/3 to the denominator. So I have 2 plus x over x to the 5/3 equals 0. And so to set a quotient equal to 0, I set the numerator equal to 0. So 2 plus x, or x plus 2, addition is commutative, x plus 2 equals 0. So I have x equals negative 2. Now this is a solution. There's not an issue with a negative on this one because I have an odd root. So x to the 5/3 could have been rewritten as the cube root of x to the 5th. And so a cube root, we can substitute negative values underneath there. The only issue with this expression on the left would be plugging in a 0 because that would make the denominator 0 and the whole thing undefined. But negatives are fine. So it's even roots that we have an issue with, not odd roots.